In order to get this question right, you need to know something about password security. Now, every time you see randomness before hashing, that's a textbook flashcard definition of salting. So that's the shortest explanation I could give you. If you are ready for a longer one, I'm actually going to move away from my chalkboard and do a little bit of a screen share to explain to you what hashing is and then what salt and where salting comes into play. What I have pulled up here is a hash generator to explain hashing and then salting. So when we authenticate or log in with a username and password, the user is going to type in their username and then they're going to type in a password. The database stores that password. Now, ideally, it's actually not storing it in plain text, we call it. That is bad because imagine if the attacker were able to steal or hack and get access to that database. They would just see all the passwords in plain text. So rather, we can store the passwords as hashes. And all that really means, if you don't know what a hash is, it's usually used for integrity because when the stored hash that corresponds to that username is in the database, next time I log in, if I correctly type in my password, which is password, what do you notice? The hashes match, therefore I should be authenticated. But imagine if I had a typo when I typed it in and I did an extra D, look at that, the hashes are totally different. So that's a long way of saying when you actually log in, an authentication database isn't necessarily looking at your plain text passwords to make sure they match, they're looking at the hashes to make sure that they match. Now, hashing is one way. Meaning, ideally, you shouldn't be able to go from the hash and go backwards to go figure out what the plain text password was. But there are tools such as a rainbow table that actually allows the attacker to sort of reverse and find out the plain text password from the hash. Especially if you're using a bad hashing algorithm, that makes it a little bit easier. So that's a long way of saying when we want to introduce a little more security, what we can do is we can take the user's password and then add a random string of characters before that password gets hashed. So it's going to be something like truly random string of characters, and that changes the hash. So this is significant because imagine if you were the attacker and you got this hash, even if you were able to go backwards, you wouldn't know what's part of the password and what's part of the salt, we call it, which is this random string of numbers and letters that's going to introduce some randomness. Going back to the question, when we introduce any randomness before doing the hash, that's called salting. By the way, if you didn't know this question or all of this language was confusing, you could have at a minimum got rid of 2 and you go from a 25% chance to a 50% chance. RAID, what is that about? That's about redundancy. That's about availability. So that's not relevant here. And then the other one that's kind of totally out there is asymmetric encryption. That has to do with public keys and private keys, right? So in that case, we're certainly not dealing with any form of hashing. It's not relevant. And then you can choose between B and D. I'm not saying that's the ideal approach, but you are going from a 1 in 4 chance to getting rid of 2. Now you have a 1 in 2 chance. So you go from 25% odds to 50% odds. If you really have to guess on test day, at least get rid of 2.